So there's the PC board cleaned and ready to repopulate. We've got a new replacement. We're just going to fit it back in. It doesn't matter direction because it's an on-off switch. It's known as a double pull, double throw. You've got two sides and it goes two directions. So this is your constant on. This would be on one side, on the other. And this is a new set down here. Constant on one side, on the other. So once we're down and pressure fit all the way in, because we've got to make sure it fits back into the box, we'll come over here and we'll solder it back in. Just applying enough heat to the board and to the pin to get a nice solder flow. Working it around for my visibility so I can control the heat of the iron and not burn any wires. Looks good. Now if you notice, the old one had its legs cut short. Just based in comparison, considerably longer. Not a problem. Let's cut off what we don't need. Alright. So now let's fire it back up and see if it works. First, let's get rid of this. Let's fire it back up. Typically, I want to test things out of circuit, but because of how simplistic it is, we can go ahead and do it in circuit. We'll just tighten this on for the fun of it. It should work under battery as well. Indicates that input needs to be on to turn on the battery. Again, no light, so this lets me know that there's another problem. Oh, there we go. Now it wants to play. So there's probably a loose connection since I'm pushing up on the back with my finger. Let's see if we can't falsify the issue. Right there. That would have been interesting. Now it doesn't want to shut off. Input jack. Let's pull the battery for a second and go to hard power. There you go, nice solid glow. It went away. Excellent. So that tells me that the battery's probably low in voltage. Should be around 9.5. So switch over to DC and we'll check it. Positive, red to black. Yeah, 4.9. It's just on the verge of being able to turn on the pedals. That's probably why we're having issues. Excellent. So while we're in it, we'll go ahead and finish the service. If we can gain access, looks like in order to do it, we're going to have to pull the... So let's get a smaller screwdriver. These are pressure fit knobs, so we're just going to gently work them up. I like to keep them in the order that they came off so we can put them back on how they came. And just be gentle. Apply a firm pressure, but don't force it. You don't want to snap anything. Take your time. Then we have washer collars. Again, the little screwdriver will come in handy. Usually once you get the screwdriver under, you can just twist it, and then that's enough leverage that you can get a hold of it with your fingers. Just a little bit bigger. Typically everything's just a little bit tighter than pressure fit, so it doesn't take a lot to break them free, and then you can do it by hand. I'm not a big fan of using power tools. They tend to strip things out and then you can't fix those. You just have to start over and replace them, so that second or two that you gain tends to cause more problems at the end of it. Alright, now we should be able to have access. Push that up. Right. We have some lock collars we'll have to put back on. But this gains access to the potentiometers. What we're shooting for is that tiny hole so that we can inject some contact cleaner that's specially made for potentiometers. It's not actually contact cleaner. Contact cleaner eats away carbon, which is how these potentiometers give you resistance. So if you spray it inside of there, chances are, as the pot sits in one fixed position, when you go to use it later on, you're not going to have any carbon left in that trace, and it'll be a dead spot. So we just exercise it, getting the lubrication inside the potentiometer. And we can put these back on. Take that out, we'll kill power. We're just going to put the nuts on, reverse the process, and button it back up. We're done. That's how you repair and fix a faulty hotcake. That one's hard to get a hold of. There we go. Just reseating the collar bushing. And these are D-shaped knobs, so they're only going to fit in one way. Line them up, press them in, on they go. Full function, they roll smoothly. From here, if there's any issues in the static, once we power it on, we can just exercise the pots and again work that lubrication back and forth inside of there, cleaning off the wiper. Go ahead and tighten this down as well. And straighten that out for looks, not that it matters for function. But it does hold the battery in correctly, so we'll tighten it. Go ahead and put this battery back in for now. Make sure the back plate goes back on. I'm going to put in 2 screws as a test so that when we fire it back up, we make sure nothing's shorting. Something somewhere is shorting. Something's against the back panel. Or it could be the fact that having that dead battery in doesn't get isolated from the circuit. So let's pull that out as well. But looking back here, oh, they do have tape. So with any luck, that tape is enough to isolate the circuit. But if you look across it, it does push pretty firmly right against the back cover plate. Honestly, in my opinion, not the best design, but it is what it is. We still have issues. So we've got a dead short somewhere in the circuit. It's pretty typical in pedals. They make them as tight and compact as possible because that's what, as a guitarist, you need. But so this confirms again that we're shorting out against the back panel. So I'm going to grab a piece of isolation and I'll put it in there, and that should solve any issues.